Hi, my name's Brianna. I'm in Professor Marshall's class, and today I will be trying to turn this into a bismuth crystal. And today my brother Steven. So here's up close of kind of what it looks like. It's a silvery colored element, metal, and then but in different lights you can see like the pinky blue tone of it. And this is 3 pounds.
Wow.
All right, so we're gonna try to melt it in this butter pot. It says the smaller the pot, the better the crystals come out. So put it on high. Yeah. It's because the deeper it is, the farther down and the bigger crystals you can make from it. So
But the bigger the pot you have to have more crystal, right?
Yeah, which is expensive.
Hi. Get it up. And if you're wondering why the jamming music in the background is playing, it's because we're doing a little spring cleaning right now. So, I hope you enjoy the vibes of Jamaica. Really, you're gonna stop it, Bree?
Sorry. Oh dang it, it didn't even work. So we're waiting for it to start melting. Hopefully it will. But while we do that, I'm gonna stop it. It's melting.
That's how you said it?
Yep, it's melting.
It's melting.
Okay, so bismuth is an element that is on the periodic table as number 83. Its melting point is 520 degrees Fahrenheit and 271 degrees Celsius. And then its boiling point is 2,847 degrees Fahrenheit and 1,564 degrees Celsius. We use bismuth for multiple things. We use it in makeup and medicine, and for like bullets or like other metal like hybrids. We use it in cosmetics for like yellow pigments or white pearly pigments. Bismuth oxide is used for yellow pigments in makeup, and bismuth chloride oxide, it is used to make white pearly a white pearly effect in cosmetics. It's a non-toxic metal, and it's silvery, as I showed at the beginning of the video. That's kind of like, and then in different lights it like looks a different color. Just added that. Probably shouldn't be sticking my finger in the pot, but it's fine. All right, and there's that melting.
It's not fine, actually.
Also, I'll give you some fun facts while the rest of the bismuth or finishes melting. So some things that we use bismuth for, like I said, were like bullets. So instead of lead bullets, we can use bismuth as a replacement, so have bismuth bullets. I already mentioned the cosmetics that we use it for. Medicine, one of the most common things that we find bismuth in is Pepto-Bismol. Kind of goes with the name. So bismuth is hard for us to recycle just because we don't have the right technology for it, and we have certain technology limitations that keeps us from doing that. China, Peru, Mexico, and Bolivia are the main suppliers of bismuth, and that's normally where we get most of our bismuth from. And we extract about 9,000 tons of bismuth annually from the Earth's crust. And then bismuth is nearly twice as common to be found in the Earth's crust as gold. So it's a super common metal that we find and use.
If bismuth is so common and it's easily found, why is it so expensive?
That's a great question. I think just a lot of different
high market value.
I'd say that, and then it also, like, since it's so like it's used a lot, then that that's part of the reasons why, or the things we use it for is what kind of makes it so expensive. So like I was saying, like we can combine bismuth with tins to make like a hybrid like metal that's that has a low melting point, because it's one of the only metals that have such a low melting point. And like I said, just for everything we use it in. And then it's not as developed, I'd say, or we don't know as much about it to where we could really use it for everything. Another fun fact, bismuth, its liquid state is actually more dense than what it is as a solid state.
Wow.
Yeah, so that's one of the only few metals that are like that as well. One of the websites I was researching off of, that we're trying to eliminate like lead water pipes and everything. We're looking to change lead water pipes to bismuth, just because it's non-toxic and then it could be more beneficial. But I think they're still testing. Okay, now that it's all melted, I'm turning off the stove top so it can begin this cooling process. And then I'm just gonna skim the debris off the top.
What's great about this stuff is, about the debris,
We can remelt it. Yep.
it's pretty cool.
All right, so we're just gonna leave it for a little bit and we'll start moving it around in a little, make sure it doesn't basically freeze to the bottom as it cools down. Oh, still not hard enough yet. Okay, so I let it sit for a little too long, but look, some crystals formed. And once they hit the air, they'll oxidize different colors. So I'm taking a few more layers off the top. And now I'm just kind of waiting for it to start to cool, so then I can make sure it doesn't freeze to the bottom or to the sides.
Look at that right there that you just poked that hole.
I know, that blue. I don't know if I'm supposed to even be touching it.
Trial and error, right?
Yep. Colors that are forming, those are crystals starting to grow down. Oh, I forgot to say this in like the information part. The bismuth crystals grow downwards, so that's why we have to constantly poke it, make sure it doesn't start freezing the sides or anything like that. Look at all those colors, that's beautiful. We can pull any out. Once we can.
Oh, look at that one. That looks a little, like almost like gold.
Mm-hmm.
Or like a rose gold.
Mm-hmm. Yeah, we are on our third try melting down the bismuth. It's melting now. I have a little ceramic bowl heating. We're gonna try and make like a little geoid with crystals in there, so we'll see how that goes. All right. Should I just pour it all in there?
No.
I was gonna say,
Well, you might as well.
I was gonna say it'll all fit.
Professor Matthews, please give my sister a good grade.
So we are just kind of letting it cool right now, and in the ceramic bowl, seeing what we get. Oh, some stuff is starting to. Sides are starting to harden.
How's it coming?
I'm trying to do the geoid right now.
Oh, okay.
So I think I could take this out. Oh, that's a really cool piece. Can you hold the phone on it?
Mm-hmm.
Okay.
Do you need your safety gloves?
Probably, but It's no fun with safety, right? And I'll just do that. And then now I'll put them on and I'm gonna pour the metal back in there. And actually that was a pretty good grip. I just have to, hot, 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 hot. Oh, I think I have a pretty good grip on it that way. Okay, there we go. Now the hot liquid's out. Okay, we just have to wait for it to finish cooling though. But I don't know if you can maybe get that in there. All those geode crystals in there.
It's pretty.
All right, this was the final result that we got. After 3 tries, this crystal geoid came out pretty cool with a pretty awesome view of the crystals that formed underneath. This project was so much fun, a little difficult at times. We kind of wung it, but it came out pretty awesome. Thank you so much for watching my video. Bye.